In this video, I'm going to talk to you about the physics and science behind sailing. Most people understand the concept that when wind hits your sail, it pushes your sailboat. However, this is not the whole story. If you look at the diagram here, you notice the wind is pushing down from the top, and it's hitting the sails, and it's pushing the boats downwind. This is the only time that sailing is that simple. If we look at this new diagram, we can now see the full story. We can see that boats going straight upwind are not going to be powered by the wind. We can also see that boats going straight downwind are getting direct power from the wind. In all the other angles, though, something special is happening. And to look at this, we're going to focus on one angle, and that angle is called beam reach. Beam reach is when you're 90 degrees or perpendicular to the direction that the wind is coming at you, as you can see in the diagram. Here is beam reach from the previous diagram. Again, wind is coming from the top. And notice how the sail isn't all the way pulled in. This is important because this creates what's called an airfoil. And as you might have guessed, a plane's wing is also an airfoil. Airfoils generate a lift force by splitting the air in such a way that the air running on top the airfoil has a lower pressure than the air below the airfoil. So that air below the airfoil tries to equalize the pressure by coming up and raising the pressure, which pushes the airfoil up. So now with that in mind, let's relook at our diagram with some of the components added to it. As you can now see, we have our wind coming from the top of the diagram down, hitting the sail, and it creates that same kind of lift force, although in a sideways direction, from the sail, and you can see the green arrow pointing at that angle. And now looking at the diagram thus far, we can see that there's kind of a problem here. The sailboat should be going kind of at an angle to where it's pointed, and that's not good. To solve this problem, they put something underneath the boat that counteracts the force from the sail, and that is called a keel. What a keel does is it utilizes Newton's third law. Newton's third law is for every action, there is an equal and opposite reaction. So in layman's terms, the keel essentially just resists that awkward angle of the sail by doing an equal and opposite force. So now, if we take our old diagram and we add everything in, we can see that the force from the sail is counteracted by the force from the keel, which creates a giant net force in that perpendicular direction to the wind. If you watch sailboats race, or watch sailboats who are trying to go fast, you'll notice something, and that is those boats are often in beam reach, which means that they're often perpendicular to the wind. The reason being is, like I said earlier, with all those forces combined, your boat can go faster than the wind. If you were per se doing what's called running or heading downwind, like we talked at the very beginning, where the wind directly hits your sails, then your boat can only go as fast as the wind.